Okay, this video is looking at Systems of Linear Equations module, and we're looking at section D of the textbook. Now in this section we're going to be looking at the substitution method to solve simultaneous equations. Now to algebraically solve a system of linear equations of two variables, it's necessary to reduce the equations to an equation containing only one variable. And one way of doing that is the substitution method. Now the procedure for the substitution method is as follows. Step 1, solve one equation for one variable. So that means get one equation with either x on its own or y on its own. Step 2, we're then going to substitute that rearranged equation into the other equation. Okay, that means that the other equation now only has one variable and we'll be able to solve just like we did for linear equations. We then find the second variable by substituting what we just found into either of the original equations, and then we can check our solution by substituting both values. So let's look at an example, might make it a little bit more easy to understand. Solve the system of equations y equals x plus 3 and 2x plus 3y equals 19 using the substitution method. Now we are going to be looking at three methods of solving, so it's important to use the method that you're being asked to use. If a method isn't specified, you can do it whichever way you want, but in this case it is asking for the substitution method. So let's label our equations. I like just labeling them 1 and 2. You can use whatever labeling you like. You can use A and B, it's really up to you. Now this equation already has y on its own. It's got y equals x plus 3. So I can go straight into substituting. And how I'm going to substitute is I'm going to get this y is x plus 3 and I'm going to put it where that y is there. Okay, so I'm going to sub 1 into 2. So that means that 2x plus 3 lots of y, but y is x plus 3 equals 19. Expand my brackets out. 3 times x is 3x, 3 times 3 is 9, equals 19. Collect like terms. And now we need to isolate the x. So first thing I need to get rid of is this plus 9, so I take 9 from both sides. So now I've got 5x equals 10. X is being multiplied by 5, so I'm going to divide by 5. So now I've got x is 2. Now to find y, I just need to plug it back into this first equation. So I'm going to sub x equals 2 into equation 1. So y is going to be x, which is 2, plus 3, which is 5. So my solution is x equals 2, y equals 5, or we can write it as an ordered pair. Okay? Now once you've finished, it's good to check your answer to make sure you're right, because you never know, you may have made a silly mistake. Look at your first equation. You found that x is 2, y is 5, so that means the right hand side is going to be x plus 3 is 2 plus 3, which is 5, and that is equal to my left hand side, because the left hand side is y, which is 5. Look at the next equation. Left hand side is 2x plus 3y, so that's going to be 2 times 2 plus 3 times 5, 4 plus 15, which is 19, which is my right hand side. So I know that my solution is correct. Now let's look at another example. Solve the system of equations 2x minus y equals 8, 3x plus 2y equals 5 using the substitution method. Now in this example, both equations have an x and y on one side, so we need to isolate one of those variables, have one equation with only one variable on one side. So 2x minus y equals 8, 3x plus 2y equals 5, equation 1, equation 2. Now looking at those equations, which one is easiest to get a variable on its own? Well, this x is multiplied by 2, so it's not singular, but the y is singular. That's just a negative 1y, so that's the easiest one to isolate. So to rearrange that equation, I've got 2x minus y equals 8. I can add y to both sides so it becomes positive. So 2x, negative y plus y is 0. So that's 8 plus y on this side. Now to get y on its own, I just need to get rid of that plus 8. So I take 8 from both sides. So I've got 2x minus 8 equals y. So my new equation is y is 2x minus 8. That's equation 1. And 3x plus 2y equals 5 is equation 2. So I've got y is 2x minus 8, and I'm going to put it where that y is there. So I'm going to sub 1 into 2. Now please remember, you can be substituting equation 2 into equation 1 if that's where your isolated variable is. You can also be getting x on its own. Okay, it really depends on what you're dealing with. So we've got 3x plus 2 lots of y, which is 2x minus 8, equals 5. Expand my brackets. 2 times 2x is 4x. 2 times negative 8 is negative 16, equals 5. Collect like terms. 3x plus 4x is 7x. Take 16 equals 5. I want to get x on its own, so I need to get rid of this minus 16. So I'm going to add 16. So that means 7x is 21. X is being multiplied by 7, so I'm going to divide by 7. So x is 3. I can now substitute x equals 3 into, now do it into equation 1. You could substitute into equation 2 if you want, but in equation 1 we already have y on its own, so it's easier. So y is 2 lots of x, which is 3, minus 8, so 6 minus 8, which is negative 2. So my solution is x equals 3, y equals negative 2. All written as an ordered pair, just like that. Now to check, I've got 2x minus y equals 8 was my first equation, and x equals 3, y equals negative 2. So my left hand side is 2 lots of 3 minus minus 2, so 6 plus 2, minus minus becomes a plus, is 8, which is my right hand side. So that's correct. My next equation, left hand side, is 3 lots of x, which is 3, plus 2 lots of y, which is negative 2. 3 times 3 is 9, 2 times negative 2 is negative 4, so that's 5, which is my right hand side. So I now know that that is a correct solution. What do you need to do now? Well, it's important to practice. In the textbook under Syle D1, there are a number of questions that you can do using the substitution method. If you have any problems, please ask for help.